Okay, so for today, now we're going to actually play with properties of exponents. So we can simplify things with exponents. And of course, these can be rational exponents. So again, they're going to resemble a fraction with a numerator and denominator. Some basic reminders, right? If you're a rational number, we can write you as a ratio. All right, so as long as you are not a fraction that refuses to terminate, or a decimal that refuses to terminate, or a decimal that refuses to repeat, you can be written as a fraction. And so all of our rules with exponents still apply. Maybe you remember these from pre-algebra and algebra. Maybe you don't. But when you first learn these in pre-algebra or algebra, you probably just use whole numbers or maybe even integers. But of course, we're going to be using rational numbers. So we'll have some fractions involved. The basic rules. A and B have to be real numbers, right? So real numbers for A and B. And then M and N have to be rational numbers. So notice that A and B can actually be irrational. We don't mind if the base is irrational, but we can't manipulate them if the numerator is irrational. All right, so A and B are going to be bases. M and N will be exponents. So product of powers. If you see an exponent product of powers. If I've got a to the m times a to the n, right, I'm multiplying. Notice the bases have to match. We can just add the m and n together. Power of a power. All right, so if I got a base of a, I'm going to raise it to the m power, and then that gets raised to the n power. This is where you have an exponent raised to another exponent. You just multiply those exponents together. Power of a product. If a times b, if the whole thing is being raised to the exponent of m, that's the same as a raised to the m times b raised to the m. Negative exponent, of course, this will lead us to a reciprocal. All right, so if you got a raised to the negative m power, it of course would be 1 over a to the m. Notice in this case there's a restriction. A cannot be equal to 0. We're not allowed to divide by the number 0. So usually we'd say that a could be any real number, but in this case there's a restriction. 0 exponent. Any number raised to the power of 0 comes out as the value of 1. Again, a restriction here, a cannot be 0. 0 raised to the 0 power is undefined, right? Because we kind of got a basic problem there. Because we normally say 0 raised to any power is 0, and then we say any number raised to 0 is 1. So we got a slight contradiction with 0 raised to the 0. So that's why we say no, we're not going to have 0 raised to the 0 power. Quotient of powers. Of course, quotient is that buzzword for division. Notice the bases have to match. They both have to have a base of a, and then I can just do a shortcut by subtracting the exponents. Again, the restriction a cannot be equal to 0 because we cannot divide by 0. Power of a quotient. Notice that a and b can be different numbers, but if the whole fraction is being raised to an exponent, we can do the numerator and denominator separately. We can do a to the m power divided by b to the m power. And notice here the restriction is that b cannot be equal to 0. Again, we are not allowed to divide by the number 0, breaking the laws of mathematics. Okay, so let's look at some examples. Let's try to simplify. 9 to the 1/6 times 9 to the 1/3. Like, hey, they both have a base of 9, so I'm in business. And I know that I can add the exponents together. So I've got 9 raised to the 1/6 plus 1/3. The 1/6 plus 1/3. That's right, we need a common denominator. So I can rewrite 1/3 as 2/6. Now if I have 1 6 plus 2 6, that makes 3 6. So I've got 9 to the 3/6 power. Of course, 3 over 6 reduces to 1/2, so I'm really looking at 9 to the 1/2 power. And of course, the second root of 9, also known as the square root of 9, will be 3. 4 to the 5th times 3 to the 5th. The entire thing raised to the negative 1/5. Now the bases don't match, but notice those exponents match, right? 4 and 3 are both raised to the 5th power. So I can actually multiply the 4 and the 3 together. 4 times 3 is 12. So I've got 12 to the 5th power. And then, of course, the shortcut here is that I can multiply the exponents, right? I've got an exponent raised to another exponent. 5 times negative 1/5 is negative 1. And, of course, 12 to the negative 1 power, that's just 1/12. 5 divided by 5 to the 1/3. Bases match, so I can actually subtract the exponents. If you're like, hey, what do you mean exponents? Well, if I just see 5, I got to remember that's 5 to the 1st power. I need a common denominator, so I will think of the number 1 as being 3 over 3. So 3 over 3 subtract 1 over 3 leaves me with 2 over 3. That does not simplify, right? Sometimes we get some really nice, neat, tidy answers. Sometimes the answer, wow, it's like looks kind of crazy. It's like, hey, I still have some rational exponent involved here, right? Or you might have a fraction or something. Oh, and instead of underdog, this time coming to our rescue is Super Chicken and his friend Fred. All right, so there is Super Chicken and Fred. And no, there is not a mistake here. Fred wears a sweatshirt with an F, and the F is backward. That's how it actually was on the TV show.